Hello, everyone. My name is Alexander Mocano. I will be your host and moderator for today's session. We are slowly moving to the end of the schedule with the bootcamp sessions. We are on session number 9, Seismic Facies interpretation using machine learning. And today we'll have a presentation from Mihir Gandhi, David Manzano, and Sachit Saumya from SLB. Before diving into the topic, I will take a few moments of your time just to quickly present one of our sponsors, one of the sponsors of the GeoHackathon. The company is called OPEX. It's an acronym for Oil Field Production Enhancement Consulting Services, which happens to be actually the company I'm also working for. We are a team of 12 engineers with an accumulated oil field experience of over 300 years. We specialize in proppant and acid fracturing, geomechanics, matrix acidizing, multi-stage completions, well intervention, offshore operations, stimulation vessels, sand control, new technology evaluation, testing and implementation, as well as project management. And with this, we help our customers optimize their assets, production. And here's a non-exhaustive list of the services we provide to our partners. The candidate selection for reservoir stimulation. We do geomechanics modeling for hydraulic fracturing, including stress anisotropy, well completion concept and design work, preparation and evaluation for tenders on behalf of operator for the services, mainly stimulation services to be provided, production modeling and forecast for economic optimization. We work on hydraulic fracturing design, materials and fluid selection, as well as optimization of fluid recipes, field operations, everything from planning to execution supervision, auditing of processes and equipment, project management, and as well, we do our best and we use our experience in providing training courses as well. As I said, I won't bother you too much with this. If you have any questions or if you have any reservoir production related issues that you're struggling with, please check our website or please contact us on one of the emails provided here. Without further ado, we'll dive into the subject. I will present shortly 3 of our presenters today. We'll start with Mr. Mihir Gandhi. Mr. Gandhi is a SLB Europe AI and innovation technical expert based in Netherlands. He holds a computer engineering degree and extensive experience in data management, digital transformation, business process management, project management, and customer support. Over his 17 years of a career with SLB, he held various digital positions with SLB India, Qatar, and Netherlands. In his current assignment, he does customer engagement on AI and innovation, undertaking such planning, evaluation, proving AI value, and bringing domain-focused innovation to solve customer business challenges. Our second presenter today is Mr. Sachit Saumya. Mr. Sachit is SLB Europe AI Innovation Customer Engagement Coordinator and Data Science Technical Manager. With a master's degree in applied geology, he has extensive experience in spending over a decade working with customers in Middle East and North Africa, Asia, and Europe. He specializes in drilling, logging, wellbore, petrophysics, reservoir and production engineering, well integrity, and data science. With 6 patents in AI and machine learning and over 15 papers and conferences and peer-reviewed journals, his focus remains on bridging the gap between domain and data science. And the third presenter will be David Manzano, also from SLB. Mr. Manzano is a domain data scientist and geophysicist specializing in interpretation and data processing. He earned his bachelor's in geophysics from National University of Mexico and a postgraduate certificate from the University of Texas in Austin. David has held various roles throughout his career, ranging from interpretation geophysicist to project leader. His proficiency in AI, machine learning, and seismic interpretation has fueled innovative projects that integrate domain expertise with data science. Gentlemen, thank you very much for joining our GeoHackathon and for openness to do the presentation and share your knowledge in seismic facies interpretation. Without further ado, I will pass the stage to Mr. Mihir.
Hello, everyone. Let me now share my screen. So over this duration of 2 hours, we are going to talk about various topics that we have covered in this, which you will see. So let me share my screen. Can you please confirm that you can see my screen?
We can see it, Mr. Mihir.
All right. Thank you so much. Hello, everyone, and good afternoon, good evening from where you're joining. Very excited to be part of this session, and thank you, SPE Organizing Committee, for giving us this opportunity to share with the community what we have to offer, as well as what we are doing. And maybe next year in the hackathon, we are going to have more, even deeper participation. Right. So introduction is already done. So let me just quickly go through the agenda for today's topics. So introduction is done, as I mentioned. Then I'll be covering this context setting and why we are doing the AI and machine learning in SLB and what our customers are asking us to. Then Sachit will take us for the deep dive into data sciences and platform. And then the later part of the 1 hour or so, where David is going to talk about the seismic facies interpretation, which is very much the topic of this, right? So before I begin, just wanted to do a little introduction of SLB, right? So what SLB is, and I'm sure a lot of you, or most of you, are aware. I'm not sure how the audience is coming. They are coming from different universities, or they are working for any organizations and all. And that's why I just thought that maybe a very short introduction on SLB. So we are driving energy innovation for the balanced planet, right? And as you see in our logo, this is a carbon curve, which is net zero and then going negative, carbon negative, right? So we predominantly started in 100 years, almost 100 years back in France. And now we are working in more than 100 countries worldwide, right? And our starting was in oil and gas service provider, but last year we rebranded ourselves, and we are now more into energy companies, not just oil and gas, but for geothermal, for gas and wind and turbine, and all the new energies that is available in the market, right? So now we are providing services in all of these industries that is coming as a new energy arena, right? So with that, I'll talk a little bit about why we started doing data science or machine learning or artificial intelligence in SLB, and how it all originated and what was the context of it. What are the challenges that we are seeing that while doing these projects with our customers, and what sort of solutions that we have, and what is our experience so far, right? So if I just talk about purely from a domain challenges, for example, for geothermal wells, so there is always this challenge that comes from our customer that I want to optimize my geothermal well placement strategy, right? So that I place the well in the right spot, so I have a right energy source, and then I can basically have a well which is optimized, right? So that generally is a requirement which comes from our customer, from a domain users. And second level of challenge comes from domain as well as mix of business, where they see the geothermal as in, maybe you have covered this during this previous sessions that you had in this GeoHackathon, where geothermal well drilling and the operation itself is a very budget operation compared to the oil and gas, because the return on investment is a multi-year time frame, and that's why everything we do in geothermal is it has to be a very cost optimal, and it has to be bare minimum, right? So that's one of the requirement which comes from our customer, that what are we offering to our customer where we can help them to drill well efficiently, right? So this is another level of challenge that we see. The third level of challenge that we see is to run the localized interpretation scenarios quickly and multiple times, right? So that they can reduce the uncertainty in the complex geological settings. So that's also one of the challenges that comes from a planning stage of the operation. Then there is always this requirement. Now it is not just for geothermal, but it is for across the board, whether it's oil and gas, geothermal, or any other energy source that our customers are trying to explore and exploit, right? So they are saying that we have tons of documents, and we try very difficult to find the critical information in a structured way. Do you have any magic solution, if you like? So they come to us with those sort of requirements. The second, another set of challenge that comes to us, which is I want to run my fault interpretation 20 times faster, for example, right? So because they have a huge seismic data, and then they want to do somehow automatically seismic fault interpretation or horizon and interpretation, right? So these are the challenges. Then another set of challenge which comes from our customer is, I have a lot of log curve images, and can you help us to make sure that we jump to a relevant page of that document, so that we don't waste time scanning through the documents and get to the right information, right? Then another example that we see, which comes very frequently, is we have multi-domain, which is basically the field development planning side of it, where and running the property models in a short time and with the minimum resources or minimum commitment, if you like, and so that because the subsurface is very challenging and time-consuming to explore, right? And then this is not just the only list of the challenges, but then the last in this list is again around the logs, where a lot of our customer has a lot of this data, which is either in paper or they have data in digital documents, but not really in a last file or DLIS file. And that's why they have no other option, but they are basically ignoring it. There is no way they can find this information into more applicable use. Right. So why I'm talking about these challenges is because when we hear our customer, when we talk to our end users, they come to us with their domain challenges. They don't tell us that can AI solve my challenge, or can machine learning solve my challenge, right? However, when all this list that you see, we do have solution in a varying frame, right? Meaning that, for example, we have localized seismic imaging, we have machine learning for property modeling, we have machine learning for seismic interpretation and things like that. So all these ideas that came were coming from an original source, from a challenge, and then we thought whether applying machine learning or using machine learning in a particular solving a particular challenge, whether it's applicable, not applicable, and how do we solve it, right? Sometimes we simply do a domain innovation and there is not much applicability of AI, but these are the solutions that we develop and we offer to our customer, right? And so now this domain challenges we do a deep analysis of how these challenges are coming, right? So what is the source of this? Why customer is facing this challenge? And it comes down to this business KPIs, right? So business KPIs are set at an organization level where CTOs and CFOs, they are basically having this or at an organization set the KPIs that I want to reduce, let's say, my 20% CO2 emission, for example, from my running operations. I want to reduce my lift cost. I want to, for geothermal, whatever the different KPIs that the industry may have, they have these KPIs, right? So all these challenges that you've seen before, if you really group them into, then this comes into this 6-7 buckets of the business KPIs, right? So whatever domain users are saying, they have a request for a particular solving a particular challenge because they want to help their organization to solve their business or to support their business KPIs, right? So we in SLB, we have realized that AI and data democratization is really something that our customer need to do, as well as we need to help our customer to solve that complex challenge that they are facing, right? And that's why we started using AI and machine learning in various of the solutions that we are doing and we are offering to our customer, right? So this is just to give you a context of why we started and why we monetize basically this services that we are offering to our customer, right? Now the next part is AI is sounding good. There is a lot of buzz about it. There are a lot of challenges also associated with it, right? And maybe you, in working in the field, maybe you are very much familiar of that, right? So one of the challenge that we faced initially when we started doing this is scaling the AI solution, right? So what we have experienced is generally that 1 out of 10 data scientists' work is actually being useful for an organization, for a company, right? We also have seen that mostly 10 to 11 or 10 to 15% of the work that is being done by various data scientists is majority of the time which is being used. So it's not able to scale to the larger population or the other data scientists who are working for the organization. And then the cycle for developing this prototype to really making it to the production, so that's a cycle time. It's very high, which is 9 months in typically small or medium complex projects, right? And on top of these challenges, we see that the entire machine learning ops cycle or the infinite loop that you see, the major challenge comes in the deployment, right? So you will see that a lot of organizations have data scientists. They can build the machine learning projects and models, but the challenge comes into really the monitoring and making the continuous improvement of feeding that machine learning model with the new information, and then optimize that machine learning model, and then again reapply that, right? So these are one of the challenges that we saw, that if we just do a simple Python-based approach, then this could be one of the bottlenecks when you start to scale this, right? If you have a company of 4 or 5 people and only 1 or 2 person running the show, then maybe it's all manageable because the scaling is not a challenge. But when you talk to companies who are not just operating in one location, one department, they have various departments, multiple locations, then the scaling is a really big challenge. The second challenge is coming from operationalizing, so that people start using it and making best use of the workflow or the prototype to the production environment, where we see various challenges, right? So as you see these phases, so these are the human versus the technology which mix together, that creates a lot of challenges. So I mean, you can read through the slide, which is about from the IT operations. They want to make sure at an organization level that whatever models we are developing, it has to be secure and it's compliant to their policies. However, if you see the domain side of it, they want to make sure that they have a single place where they can collaborate with the data scientists. Now, data scientists have different challenges, which is they have a different code environments and multiple languages. How can I integrate? So those are the typical experience that we have. Now, we also realize working with so many large companies is companies don't standardize on one particular platform or one particular applications or one particular software vendor, if you like. So they have lots and lots of mix of solutions in place. They want to develop new solutions, and that's where they see a lot of challenges which comes to operate this AI a workflow or a use case that they may have developed and continuously use it, right? So these are the second challenge. The third and the biggest challenge, or also it's an opportunity, every challenge is an opportunity, right? So what we see is a lot of companies are now started doing their citizen empowerment, because there is a very clear requirement from across the board, which is the need for using AI is not coming from IT, but it's coming from the domain users, as in our industry, right? Maybe it's coming from geologists, drilling engineers, production, whoever is involved in that overall operation of the company. So it's coming from those user groups, and the challenge is those user groups are not really very well versed with the computer science or the machine learning or the data science as in technology and tools. And that's why there is a lot of drive from companies that we have seen who wants to create citizen data scientists, because they understand their domain, they understand what they are doing and what needs to be done. And they also need to, they also have a better understanding of what data science world is and what to apply where, right? So this is where the right mix happens. And we see as this challenge is getting not really super resolved, but it's managed, I would say. So in that situation, what is happening is there are so many ideas in companies that they want to solve. Some of them are duplicate attempts from various organization level. They can combine them. Some of them are not valid anymore because it takes long time or it has its own complexity. So basically, if you have a lot of people doing good innovation, then in that case you can streamline this innovation, and you have basically a pipeline where you have mature ideas getting used in the organization, right? So citizen empowerment is really getting a lot of challenges as well as a lot of traction, because that's where the organization see there is a lot of value, right? So on SLB side, this is my last slide though. So on SLB side, what do we offer and how do we manage these various challenges, right? So we have seen various customer personas and various customer profile, meaning that what is their appetite. So some organization have already data scientists in their team. They already have citizen data scientists, meaning that the geologist or geophysicist have idea of what data science is, and they can start doing the mid code or no code, low code type of environment, right? So if for those organizations, we offer them our AI platform, and it's available both on premise as well as on software as a service. They can subscribe for it, and they start building their own workflow so that it's a central environment where they start doing their own workflow. The second pillar that you see is where there are organizations. One is they may have data scientists and domain experts, citizen data scientists, but they are fully occupied. They don't have bandwidth to do more. That's one level, one side of organization. Second is organization where they don't have a lot of expertise on the data science and even the domain science or the software technical expertise, if you like. So those organizations engage with us through our innovation factory as in framework. So you see, it's not a wrong spelling, but it's AI used in a lot of these workflows that we develop for our customers. So it's a joint development. Customer gives us feedback. We have a team of data scientists and we develop a solution for them, and then they basically start using it. That's the second. And what you see on the third pillar is where we are addressing this empowerment, citizen empowerment challenge that I talked about, right? So we have a very niche, specialized domain courses that we run for our customer who joins us in let's say multi-weeks program, and then we end that with a challenging project for them, like you guys are going to do further for this hackathon as a challenge, and we give them this challenge, they solve this because they learn it, and we help them over the period of time to solve that challenge, right? So this is what I had to cover in this time. I hope I gave you more context of what SLB is, what are we doing. And then now Sachit is going to talk more about, especially around this AI platform as a pillar, why we are doing what we are doing, how we burn ourselves, and then we learn hard way, and then that's why we are using the AI platform. And then later on, David will go purely on the seismic faces interpretation, right? So thank you so much. I hope if there is any question, I'm available on the chat anyways, and happy to help. Yeah, thanks. Sachit, you want to share your screen again?
Yes.
Okay.
Thank you, Mr. Mihir. Yes. While Sachit is sharing his screen, I just want to mention that in case of any questions arise, please put them in the chat box as usual, and we'll address them at the end of the presentation.
Just a second, guys. Let me share again. You can see my screen?
We can, yes.
Yeah.
All good.
Okay. Now, so Mihir talked about, in general, how we see things as AI, as SLB. Now, what I want to take you through is a very important thing that happened in the AI realm itself, right? Now, 10 years ago, just to give you a context, 10 years ago, the only people who would be running data scientists would be like core data scientists. And if you ask them, they would be writing 10,000, 20,000 lines of codes. Probably even now, I mean, some of the core data scientists, they are so happy writing their own codes, right? Now, as the industry started to move towards adopting AI into their day-to-day life, and when I say adopting AI and machine learning into their day-to-day life, what it means is there are so many conventional workflows across industries, not just oil and gas, right? We have been doing those workflows in a certain way, and then we realize that there is a smarter way, there is a better way of doing it, right? Why waste time on doing these manual steps while we can utilize AI to solve these problems, right? But which was good. I mean, this is where data science came into the oil and gas industry. We had, and we sit on so much data, that it made sense, right, to have AI. Now, cut 5 years short, like 5 years ago, if you go to a geologist or a petrophysicist, whoever, right, and you go and say that, hey, I see that you have a problem, right? Do you want to solve it via AI? His first reaction would be yes, but I am not a programmer, I am not a coder, I don't know data science, so I won't be able to do this, right? So you see, one of the major problem that we also realized was that most of the domain people, right, whom we call as citizen data scientists, if you remember the slide Mihir showed couple of slides before, right? Most of the domain people can be anyone from any domain. They're not programmers, right? I mean, they have a different degree. Like for myself also, right? I don't come from a pure data science background. Now, we don't come from that background, but we want to develop solutions, right? And when I say develop solutions, either it can be develop a scalable solution, even if it is a small scale solution myself, or collaborate with a data scientist to deliver these solutions, right? So this is where the advent of data science platforms came into picture, right? Which basically meant, and it's a very interesting Mordor intelligence chart you see, that the market size of data science platform is expected to grow like almost double the size from 2023 to 2028, meaning most, and this is not for oil and gas, this is across industries. What it means is most of the industries are eventually going to adopt these platforms to deliver AI based solutions. Now, why would they want to do it? Why would they want to transition from pure codes to a data science platform, a data science visual platform, right? And one of the biggest reason is to democratizing AI, right? You cannot see, I mean, for I'm speaking strictly about oil and gas industry. Uh, while I mean, it's, you need to have data scientists, but the knowledge of domain, the domain subject matter expert SME is very important. And at the same time, if you want them to build the knowledge, which you call as democratized AI, you need to have a platform where, without spending too much time on coding, right, you are able to develop solutions, right? So this is where the first pillar of why most of the companies would adopt data science platform comes into being, is to democratize AI. Second is, at the same time, whatever work you want to do, now coming into the technicalities, the nitty-gritties of data science in general, I'm sure you guys, I was going through the the agenda, and I saw that machine learning was part of your entire geo hackathon journey, right? So I'm not sure if it has happened or it will happen, but as part of machine learning, one of the important step is data preparation, right? And also creating and connecting the data. Now, if I'm just writing code from scratch, and I have, in a real world, the data is not sitting on my laptop, right? If I have to train data on some 20,000 well logs, it's not sitting on my laptop. It's probably sitting on, not even into one database. It can be via several databases. So if I can have a platform where the ease of connecting to these platforms or these data storage, can be a SQL database, it can be a cloud-based, it can just be individual files. And if this data connection happens seamlessly, I mean, that is a great boon for anyone building the pipeline of data science, right? So this is what you expect. Otherwise, I mean, of course, if there are data scientists and programmers, they know what they have to do to reach this step, right? Now, one other important aspect is to have the element of collaboration, integration, and extensibility, right? When I say extensibility, what I mean is, okay, I developed my solution, right? Now I have to scale it and I want everyone to use it, right? Now, if you look into percentages, maybe some of them might be interested in becoming citizen data scientists, which is domain people doing data science. But a lot of them would just be end users, or what you can call consumers, right? How do you give them this, right? How do you extend whatever you have made to the consumers? You don't want to be running your script all the time. I mean, a new data is given to you, you run the script and you give the result, right? This cannot be scaled. If you really put things into production system, you cannot have this flow, right? So extending this into platforms, let's say, I don't know how many of you are familiar with Petrel, but if you are, Petrel is the geo modeling software. But if I am able to extend whatever I make over here to Petrel, means that I just go to Petrel and the platform is in the back end and I'm able to execute it. That is what I'm talking about, extensibility, right? And of course, having the all these steps, right? The end-to-end step on a single platform, right? So now what it does is the chain that Mihir showed, involving all the different profiles or personas, as we call, working together, right? So this is one of the important things that happened and will continue to happen extensively, is to transition from pure code sitting on someone's laptop, to a more data science visual platform, right? Now, again, I mean, to give you a context, what I'll be showing you would be Data IQ, but do not focus on Data IQ for a moment. By the way, I mean, Data IQ is a third-party software. I mean, you can go to Google, just type Data IQ, you'll get the context around it. It's a French company. So instead of building our own software, SLB decided that it's better to partner with someone who is a leading organization in terms of a data science visual platform, right? So Data IQ became, after evaluating a lot of platforms, Data IQ became our platform of choice, right? But for a moment, if you forget about Data IQ, don't focus on this specific platform, but what a platform really offers is are these blocks that you are seeing over here, right? The ability to connect to different storage platforms. These are all the storage platforms. The ability to orchestrate data flows, to deploy APIs, to build your models. That's on the deployment side, in terms of using visual recipes or codes, as we call it. And also for experienced data scientists to come up, if they already have Python scripts, they can migrate these scripts and then extend it to various platforms or expose it to the various end users, right? It can be the ENP softwares. It can be other softwares like Power BI, Spotfire. It can just be APIs, right? It can be public web apps on which you are able to expose them. So, okay. And again, all of this platform would be available on, it can be either on any of the cloud services, or it can be available as on Delphi, which is our offering, or it can also be available as on-prem. But again, moral of the story over here is that this is what we expect from a platform. Instead of having individual Python notebooks, these are all the elements that we expect from a platform. And what we'll also do is, while I'll go through some of the slides, we'll also see a demonstration of the platform. Again, don't go by this exact platform per se, but see the idea of how a platform can transform how we are doing data science today, right? And that's the key message I want everyone to take from here, that in the present world, it's not just codes. If there are people who are just domain people, geologists, geophysicists, anyone sitting in the call, the idea, the message that I want everyone to take from here is that the world is changing, right? And the AI world specifically is changing every day. And one important change that has happened is moving from Python codes or coders to platforms where all solutions can come into picture, and a lot of different profiles can come and deliver these solutions. Now, this is a quick view of the platform Data IQ. I mean, most of whatever I talk would be based on Data IQ, but this is how it looks like. So what you see in the center is the flow, what we call as a flow, where you have individual steps. All the blue blocks you are seeing are your data sets. All your yellow circles are your data preparation visual recipes. And all the green ones are your machine learning models, right? Now, what it also does is you get the ability to utilize your own codes. I mean, so that everyone can collaborate, right? If there is actually a data scientist, so meaning for every profile or persona, the way you can use a platform can be different. For a data scientist, a platform would be so that he can scale and deploy solutions, monitor all his solutions in one platform, and it is explainable to everyone. For no code, low code users, everyone can understand, right? I mean, and he can develop the own solutions. And yeah, you deploy it as an API, which is accessible to the end users. Now, when it comes to data processing and interpretation, what you see as the visual recipes on the top, sing, prepare, sample, group, sort, pivot, stack, there's so many of them. And I'll show you an example of it. Imagine if this did not exist, right? So the way you would be doing it is you would be writing the Python lines for it. Now, it can be 2 lines of code, it can be 10 lines of code. It can be very easy for an experienced programmer, but for someone who is a no code, low code person or a domain person, telling them that, okay, you have to write even a line of code is something, it creates a mental block, right? And we'll see what visual recipes look like. When I say visual, it literally means clicking It has clicking the button and running around it, right? Now, again, at the same time, it gives you the ability to collaborate with Python, R, Spark, right? And to develop your, if you already have pre-existing codes, or if you still want to not use these recipes but run your own codes, you are able to do it, right? Okay. Yeah. Yeah, so this is what a visual recipe. It's a snapshot, although we'll still see how it looks like. But this is how a visual recipe looks like, right? Now, if you look, it says keep only 40 columns. I can write a line of code to do this, right? If I have some 100 features, if let's say I get an Excel file, a CSV file, which has millions of rows and some 100 columns, right? And I have to only work doing the job of data preparation, and I only need 40 columns. Now I can of course go ahead and write a line of code that, okay, remove these columns, or I can do the same step visually where I select this option which says keep rows, and I can keep the rows. I can manually select, I can select that these are the rows that I want to keep, right? Now, when it comes to model deployment, now we enter, if we are talking about when we want to create machine learning models, right? When we talk about creating machine learning models, the platform, most of the platforms give you a very visual way of developing it, right? Where if you see the snapshot over here, you'll see that not only can you get some initial, now this example is of Facies prediction, right? So what you're saying is that this is a class-based classification. This is why you'll see prediction type multi-class classification. My target is Facies. And you'll see that it already gives me a statistics, right, in terms of understanding the distribution of the different classes. Now, before even building my model, I know that this is how my classes are distributed over here, right? Now, beyond this, and this is all visual again, I mean, that's the whole point. I can write lines of code to do the same stuff, or I can have a visual way of not only developing it, but making it more explainable. Just like I'm able to explain you one by one, oh, see, this is like this. And it adds that element, right? So what it does is now, when you are able to visually develop your models, is that you accelerate the process. It's not like an organization or you have just one problem in life, or one problem that you feel like data science or AI can solve, and you can take 2, 3, 4 years, right? Now imagine in a realistic case, like even for SLB, we have so many problem statements every day. If you really want to accelerate, push more and more projects into production, you need to have a system or a platform where you can develop these solutions faster, right? And if you look at the snapshot again, you'll see that there are many steps. There are the element of features. This is what we mean by features, means the columns or the inputs. Now I can manually select and remove inputs. I can see more statistics related to these inputs. We'll see on the platform also again. You can generate features, do some reduction, PCA, lasso regression. When it comes to model, in terms of algorithm, you'll see that all these algorithms are available. Now, for someone like me, let's say, hypothetically, if we do not know which algorithms to use, I can basically go and select all the algorithms, default parameters. I don't play around with the trees or the depths, no tuning of the hyperparameters, and I'll just say run. So what Dataiku would do is, or the platforms would do is, it would run all of them. Let's say in this case, if we ran only 3, it will run all of them, and it will give you the associated statistics, and also give you this trophy button if you are saying. So what this trophy button says is that depending on the model metric that you have chosen, and in this case, it's the model metric is accuracy. Depending on the value model metric accuracy, in your last session, let's say session 3 was the one, logistic regression is your best. Doesn't mean this is what you have to go and deploy, right? Because what you can then do is go ahead and do model explainability. Because you made the model, how do you know that your model is good enough? Now, of course, model metric is one way, but to do an in-depth analysis and a visual analysis of your model explainability, this is what you do. Now, I can see that these are all the features that I selected, and it's giving me the feature importance. Now, let's say after this, I go back and say that, oh, I see that there are some 10 features which do not really play a role. It's like 0.1%. I can go back again, visually, go back to feature, remove those features, and come back again, rerun it, and see the importance over here, right? So all kind of decisions I can be able to take when I have a visual way of doing this. Again, you can write lines of code for it, but having this makes it way more easier for also the domain people. Imagine a geologist sitting over here, right? Or a petrophysics who is sitting along with a data scientist. Something like this gives more opportunity to collaborate, understand, work together. Otherwise, it would be pieces of work forwarded to, let's say, a domain person. He would just QC and send it back, right? So it would be segregated work rather than everyone working together and understanding what is being done. Now, for example, if you have to just the performance, right? It's a class-based problem. You have an option to see the confusion matrix, right? Again, you can write a line of code to create this confusion matrix, or visually just see all of these things over here and then take a call, right? In terms of whether whatever model you have, or if you feel that some of the classes are underrepresented, the actual versus predicted do not make sense, or maybe another model, let's say the gradient boosting, even though the accuracy was less, whatever we selected as the model metric, but here in the confusion matrix, it makes more sense, right? So these are all the things that you add up. Now, what you can also do is at the end of the day, you can publish this to a dashboard, meaning that if let's say Mihir wants to just come and see that what has happened, so all you do is you just present these charts, you publish these charts on the dashboards, and you would just QC it and go back, meaning that he does not have to go through the entire flow, click every button, what has been done, but he'll just go at the higher level details, see, okay, these are the things that we are talking about, and go back, right? Now, also in terms of automation, when I say automation and trigger, what it means is if I want to automatically trigger the pipeline, I mean, let's say I build the model, right? And now I'm exposing it to an API or whatever, but I want it to run automatically. So imagine if there is a new file, new Excel file that comes, and let's say this new Excel file is copied to a SQL server, right? It gets ingested over here. So why are these scenarios and triggers? What I'm achieving is every time there is a new file copied and I write the right trigger over here, it will trigger the workflow to run and send the results, right? Now it can work in real time, near real time, and things like that. So what it will do is whatever solution you have built is more repeatable. You can reuse the same stuff rather than doing it again and again, right? So this was what I have in terms of slide. I would like to show you the platform. Although, I mean, when David would take you through one of like seismic facies interpretation for geothermal, you will again see the solution because the solution is on Dataiku. But I would just show you some of the elements that we discussed over here. Yeah. So this is what a Dataiku platform, the platform that I was talking about, looks like, right? Now, instead of instead of opening my Jupyter notebook right now, let's say today you tell me that, hey, I want to build a facies classification model. Instead of, okay, let me open my Jupyter notebook and start writing codes, what I would do is I would come over here to a platform and I would develop the end-to-end solution, meaning not only will I make sure I connect to the right data storage, I will do my data preparation over here, build my machine learning model, but also push it to wherever I want, right, in terms of doing it. Now, this is what the model looks like, the platform looks like, right? You see the workspace, you see the different projects over here. And the security is tight, meaning that you can share the projects with the people you want to. Even though I can see over here, I won't be able to, like, let me show you. Even if I open, let's say this, right? This is not accessible to me, right? So what it means is that you can share the projects to the people you want. So it's also secure, right? Now, one important thing in these platforms is the ability to have a lot of plugins. What are plugins? These are pre-built solutions, right? In terms of, let's say, if I have to do time series preparation, it's a pre-built workflow that I can use, and there are tons of it. I mean, on Dataiku, specifically on Dataiku, presently you will see 126. If I want to do text extraction and OCR, I already have a plugin. I can just go ahead and use this plugin as is, right? Just drop the data and run it, right? And again, it also has open AI, GPT, generative AI, which is a new buzz in town. There are also plugins related to it, using what we can do our text summarization, we can do prompt engineering, all of these things on the platform itself with the ability of these plugins, right? So you see, these are all the plugins which you can use to go ahead and basically build whatever solution I'm trying to build. Okay, but let's go back to our project. Now, this is the project, right? If I open the project workspace, this is what it looks like. You have the facies classification, right? It will show you these are the number of data sets. These are the notebooks. Some certain notebooks are in place. Every change that has been made by any of the user in this project, I can map it and see what is there. If you want to publish anything, like the best practice how to run it, you can have it over here. Now, there are no dashboards, but what a dashboard would do is you can go and, what I was saying, if you have any charts or results, you can publish on this dashboard. Now, if you go to the flow, this is what a flow looks like, right? Now you can divide it into different zones. This is your data that we have been talking about. Let's say this is the facies data that has been given to me, and this is the well log data. Right now, I can go ahead and you can see all of this. I can do some quick analysis of this in terms of how many are valid, what is the distribution, right? What I can also do is, what I wanted to show is in terms of connecting, because I've been talking about, using a platform instead of writing codes to connect to different data sources, right? All I have to do is just say if it's MySQL, Postgres, I would just open Postgres, right? Type the SQL connection that I've created. I won't do that, but if I just click on table list, it will give me the table list, and that's it. I bring the data over here. It's as simple, as straightforward as that, right? Now, if I click on the data, you see the preparation, all these visual recipes, and I said that they really look like visual recipe. Meaning, in this stage, if I had to join these two data sets, right, because the facies type were coming in a separate data set, and the facies logs, the well logs, were in a different data set. If I have to join them, it's as simple as this join recipe that you see over here. And if I open this recipe, this is what it says. A left join, a right join, and that's it. Right? And I'll just say run, and I'm done, right? And it runs. This is what I was meaning when I was talking about visual recipes. Again, in terms of data preparation step, if I say add new steps, these are all the steps that I'll see right now over here. There are some 99 processes, right? Rename, move, count, all these steps. Right? And if I have to do any of these steps, or let's say I want to remove something, I'll say remove. It says, okay, delete, keep rows by column. I'll say I just don't need the whatever, let's say ILD log, right? And it gets removed. Now I won't run this because it's an actual project, but I hope you get the message from me, right? And the same way, you can go ahead and do all the different steps related to when you are preparing the data using the visual recipes that are available. So meaning, without writing any line of code, I've done my data preparation, right? Now, without writing any line of code, I will be able to do my machine learning modeling, right? Design. Features, I can just go ahead and stop the features. My algorithms, I can go ahead and select algorithms, remove algorithms. If I want to, in XGBoost, I want to modify any parameters, I can go ahead and modify. In terms of hyperparameters, if you want to change the number of folds, cross-validation, anything related to it, right? This is where you design, right? Once you are happy, let's say over here, you are happy with logistic regression, it is giving you all these details, the model explainability that we saw over here. Once I'm happy with it, all I'll do is just go and say deploy, right? Once I deploy it, this is how you are going to say, it's saying that it's a deployed solution. And then I can just go ahead and start predicting, right? And I'll have my prediction over here. This is my final prediction, right? So basically what we saw over here is with the advent of platforms, and Dataiku is just one platform. If you go ahead and just do a search of all the platforms that are available, you'll find a lot of platforms that have come solving different kind of problems. Some are more business analyst kind of, some are more on the auto ML side. So different problems are being solved for different purposes. But the advent of platforms have come, platforms where user can come and instead of writing codes, they can go ahead and develop solutions, right? So so this was one of the most important message that I wanted to pass to everyone in this call, is that AI is changing, the way we are doing AI is changing, and as SLB we have changed, right? Now internally also, this is how we are developing our solutions. We are using Dataiku or a platform, data science platform, to not only develop solutions, and a lot of these solutions are being developed by our citizen data scientists. People now, in fact, David, who will come, David is a geophysicist. He has a very strong geophysics background, and now he's a data scientist. He's developing all kind of AI solutions, and we are using the platform to develop these solutions. Now, yes, at the same time, you can use your codes. It doesn't mean that the coding has gone away. It just means that you have a platform where you can seamlessly integrate with different data sources. You can build your model over here. You can add the element of explainability, and you can scale it and put these things into production, right? So now I would hand it over to David to actually take you through the use case that we are talking about, which is the seismic facies classification, right, for geothermal specifically. So we'll now see the integration of domain on a platform using AI, right? So that solves your entire puzzle, okay? And if you have any questions, I mean, feel free to ask. I don't know what way we are asking the questions, but yeah. Thank you. David, up to you.
Thank you, Sachit. Please post your questions in the chat, and then we'll address it at the end.
Thank you, Sachit. Thank you, Mihir. So can you hear me okay? Is all right? So I've been having issues with my headsets, so I apologize, I don't have video. But let me share my screen. Let's see if you guys can see it. All right, so let me know when you can see my screen.
We can hear you and we can see your screen, David.
Perfect, thank you for confirming. All right, so I'm gonna talk now about practical use case on the seismic facies interpretation. I'm going to start with the agenda of the presentation. I'm going to quickly give a big introduction. I'm going to talk about the data preparation. I'm going to touch on the unsupervised learning methodology that we use. I'm going to show you the results and finalize with some Q&A session. So, all right. So for the last weeks, you guys been hearing a lot of geothermal energy. So I briefly want just to point out a couple of comments. And you know, geothermal energy is a subject is growing, and it's estimated that the market size in the US is going to reach 96 billion by 2029. And with that is also estimated that it's going to have a 26-fold power generation increase project by 2050. If you look at the map here, you will have a clear idea what's going on the geothermal energy capacity. The countries on red are the ones leading on this matter, while there is a lot of white, which is it's a meaning that a lot of countries are starting on this journey, and other countries are not even there. So, but this is a lot of opportunities, right, for companies to start exploring onto this new venture. So it's very important to see where the geothermal energy stands at the moment, where is the moving direction, and understand the overall perspective. So this image that you see here comes from the Department of Energy, US Department of Energy, and it shows the timeline of development of a project. So it divided into parts: the pre-project that includes all the leasing contract and so on, and then it comes the longer part of the project, what is the development itself. And I want you to bring your attention into the first part on the second part of the whole, which is the exploration. So everything starts with exploration, similar than the oil and gas projects. So eventually you move to other kind of exploration with wells. And then once you have your reservoir more on place, you start thinking about develop and then construction of the plants and so on. But it is important to understand where the exploration taken in account into the full picture. And most important, where is the seismic playing the role in terms of exploration? So SLB Geothermal is a segment in the company. It's formed by experts, technology, and so on, and help the clients to carry along the projects since exploration, development, and we have the tools and the technology to help clients to carry over and help on these projects. So speaking about the exploration part, there are some methodologies that companies use to do exploration, specific on geothermal, and these ones are depending on some factors. So to speak some methodologies, and not necessary are all of them, but at least one of the most important I have seen is the magnetotellurics, the gravity, electromagnetics, and seismic. And as I mentioned, these methodologies applications for a specific project will depend of factors, like for instance, accessibility. If the area of the project is sitting in an urban area zone, probably seismic is going to be a little bit challenging to do there. Also is directly related with the depth. So if the reservoir or the target is deep, then we have to understand where the penetration of these geophysical models. So even though with certain configuration you can reach certain penetrations, it has these limitations. Is well known, and seismic is good to penetrate depth or deep in terms of targets. So also a geological risk, and of course, how much is going to cost, right? So those kind of the factors that at the end of the day are going to play important in to decide which is the methodology in terms to move forward for exploration, and in specific case for geothermal. So for this case, we are going to use seismic. And I'm going to use a seismic cube that has been using for oil and gas, thinking in an account that is the same principle in terms of characterize the reservoir. So we are looking here that from the seismic, we can understand the structural and the stratigraphic, which is going to lead in the construction of maps and specific from geothermal fields in this case. And also from the seismic, we can get seismic attributes. We can obtain seismic inversion, and with that also can help us to find paths for drilling for the second part of the exploration. So with the seismic, it can help us to understand the reservoir in a quantitative manner. So let's say characterize the reservoir to understand key parameters like porosity and permeability. And specifically for geothermal, it can help us to estimate the temperature of the field. So a big play a big element on the seismic, something we can obtain from the seismic is seismic facies. So the same way that we adapt the seismic facies analysis from hydrocarbons, we can use it in the same way from geothermal. So thanks to the seismic facies, we can understand the subsurface in general, and we can identify targets. So it helps to construct a conceptual depositional model, which is very important to understand the reservoirs, the geometries, the conditions. So with all this information is going to help us to better navigate geological risk, to take more educated decisions, and eventually is going to help to optimize the exploration, which is going to lead into eventually to contribute to sustainable and economic growth of the geothermal energy. So seismic is just a part of the whole process, but it's very, very important. So before I start with the flow, there are a lot of work done in terms of facies classification. So it depends of this work that has been done, use a different data sets as an input, but eventually they are looking for the same target, to classify the targets, to separate one class from another one, right? So in terms of seismic, also has been done a lot of work. Some of them based on visual dating approach, another one's using visual mining, another one using a specific cluster, other ones are focusing more on the algorithm itself. So this approach, it's kind of an approach to try to connect from end to end, going through the data science platform that was previously discussed, and to enable the user to have something usable and something ready to jump into production. So here you see three colors in the line. So the green line over here, I call is part of the data preparation, because it's really where the magic of this flow happens. Data preparation, which is mainly carried by the domain drive, is a 60–70% of the flow, as you can see here, and this is kind of the very important part. So you know that machine learning is a very powerful tool, but it's not magical, right? If you input the right data, you probably will get good results. So if you get crappy data inside, you will get bad results. So simple as that. It's not magical. So we have to make sure that we prepare the data, that we understand the data, and that we get the data that we wanted to apply for any approach, right? So the data preparation is mainly done in Petrel, as Sachit mentioned, is kind of our GeoModel main software, and the data science is done in Dataiku. So it starts with a seismic cube, selecting the area of study. Then we obtain two more inputs based on the seismic, which is the geological surfaces and the seismic attributes. Then we parameterize the grid. I'm going to explain that more in detail later. Then a step on the data cleans. Then we jump into the unsupervised learning part. Then we do the QC, the results of the QC. This is where the domain again plays a big role. And then we can deploy the model to expand the classification in another areas. So let's go for pieces. So data preparation. So this approach works on a 3D seismic cube. Unfortunately, the 2D lines are not enough to run this approach. So for this particular case, I'm using 120 square kilometers of seismic. This is a 3D migration volume with a bin size of 12.5 by 25, which means 400 inlines and each 1,000 cross lines. So it's just a portion of, this is a small cube of a big portion, an area, and also has been cropped to exclude the water bottom. So what I have is 800 meters roughly of seismic data. From a velocity from a well, I know that the velocity in the area, at least in the target, is around 3,000 meters per second. So the area of study, why is this data is important? So even though this seismic cube was used to exploration oil and gas, the same principles apply from the geothermal in terms of reservoir. So we have here a channel. Let me see if I can bring my laser. Can you see my laser?
Yes,
we can, yes.
Yeah. All right. So we see here a channel. that in the cross section is represented in this part, right? So this channel is surrounded by the levees, so a different stratus over here, and over here is something else happening. Probably I have buried channels, another channel over here, and maybe part of the same channel in this area, right? So this is my target. So the channel contains the right conditions to allocate a reservoir. So also it's good to have stratigraphic traps, and can also have a migration pathway. So this is the area I want to understand. So this is a 2D view, and it's very clear, the channel across the area. So the first thing I want to understand is what is out there in terms of solutions. So we're talking about seismic facies, right? But what I'm more interested, what internally we have done, and especially in Petrel to try to get this. And we have, I mean, Petrel is a very robust software with a lot of tools, with a lot of resources. And of course, there's one of those resources is to estimate the seismic facies. And what Petrel is using is neural networks. Is using similar inputs. I'm saying similar because it's not exactly what I need for this approach. And it requires that you have to specify the number of clusters, right? Which for me is kind of a chicken and egg situation there. The algorithm asks you to see how many clusters you want, but at the same time, this is what you want to calculate, right? So this kind of more try and error to see how much you put a number there, you see the results, if they make sense. If not, you run a new iteration and so on. So with this approach, we don't stick with one single algorithm, since DataIQ is very flexible and we can run several algorithms and with different parametrization on it at the same time, where we have more flexibility in terms of the results. And also, as was previously mentioned, we can select the metric that we want to use for the model, and that metric is going to be used to tell the algorithm to tell us which one is the best suitable for the data that you are input. So the output is the facies classes as well as the neural networks, plus a model in this case that we can use eventually to expand the classification in other areas. So one of the challenge here is, how do I represent a seismic cube in a way it can classify seismic facies? And to do that, I have to think in a 3D perspective. I have to transform this data in a sort of data that the algorithm is going to understand it, but also at the same time that capture the special 3D correlation between all the data sets. So in order to do that, we have to prepare a box. So this box is going to be constrained by 3 elements. The first one is 2 boundaries leading by or 2 boundaries via geological surfaces, and then especially has to be or is controlled by this bin size on the seismic. So basically is the seismic grid. And this is going to control the vertical scaling. So I'm sorry, the spatial sampling or spatial spacing. And the vertical sampling is going to be controlled by layers. So these layers is something I define, and these layers are directly influenced by the thickness of the layers of the geology across the area. So this is something you have to be aware when you create a box. So all these elements will play a role on it. So as you see here, these surfaces are the boundaries I am selecting. And between these 2 boundaries, I have roughly 400 meters of thickness, right? So, but now let's go and explore about the surfaces. So I need two surfaces, the upper boundary and the lower boundary. So the first thing that you can observe by the colors of the surfaces is like the upper boundary might have a little bit more of geological pattern on it, right? So you can see that the surface is trying to capture this event over here, and it goes a little bit shallower and goes down and then suddenly flat, right? Which most likely in geology that doesn't happen. So this, but I did that on purpose. I did this on purpose, and I explained you the reason later. This surface over here is a very smooth surface. You hardly can see any geological pattern on it, and it's been probably crossing events all over. And as a matter of fact, this surface over here is extrapolation and eventually a snap of the upper surface, right? So, but this is important to keep in mind, and I'm gonna show you later the results using these surfaces and why it's important to have close or more defined interpretation for these boundaries. So this is what I mean with more defined interpretation. This is an example from a different area, but this surface over here on the right is done based on a very fine grid. And as a matter of fact, for these surfaces, in some areas was using some a machine learning algorithm, a different project. But you can see here how well the geology is defined, how much patterns you can see. And just by looking at the surface, you can start creating scenarios, understanding the area in a more deeper way. So this is on just for you to keep in mind. So before moving into the grid itself, I want to touch into the seismic attributes. And this is important because the box is going to be populated by information that comes from the seismic attributes. So the seismic attributes that I have showed here are the attributes that are, let's say, better correlated with my area. So also they are based on this chart over here, which suggests based on the sedimentary environment that you have, which attributes maybe you can use in order to extract the information that you are looking for. So from the seismic, I can obtain the acoustic impedance, the relative acoustic impedance, the sweetness, the chaos, the envelope, the instant frequency, the first derivative, and the contrast. So all these attributes are going to use to fill up at the box with information. And every single of these one is kind of telling me a piece of information that eventually I need to use for the classification. So coming back to the box. So I have my two surfaces, the upper and the lower boundary. Then I have to define the number of layers. If you remember, the number of layers are based on the thickness of the layers of the stratigraphy. So roughly I have 400 meters of thickness between the two surfaces. So here I have to think now until on the sampling interval. So if you remember, my seismic is sampled 12.5 by 25. So something here I need to keep in mind in order to build the box is to keep the proportions. So if I pick a bin size of 30 by 30, that means that I'm gonna have 20 meters vertical size and 30 meters spatially, which is okay in terms of proportion. But I put these two examples here just to show you what is not really proportional. And if I double the bin size by double, then I'm gonna have a very elongated cells on the spatial direction. And opposite, if I choose a very small bin size, I'm gonna have a very elongated cells on my vertical sampling. So it's important to keep these proportions. So Basically, the number of layers are related with your bin size that you want to create. And this is important because what I'm going to do later is to populate every single cell with information coming from the different attributes. So I'm going to repeat that for every single layer. Petrel has a very smart way on to populate the 3D grid to keep the 3D sampling and the proportion along the area. So what I obtain after doing this process is a Petrel dataset point that contains the information of the location, the X and Y, and the Z, or the depth of every single dot, and every single dot contains the information of the number of attributes associated to that centroid. So, and this is how I built up the data set, which has a tabular shape coming from a 3D perspective. So also it's important here to considering that for this small area, and taking a bin size of 30 by 30, I'm creating 783,000 rows with 350 megabytes. So it's not too big file. However, imagine if I increase the area of my application. Or what about if now I want to look more finer? If I reduce that bin size by half, then I'm going to increase my data by 2. So I'm going to have more data to process. So this is something to keep in mind as well, because if you don't have like the resource power to run these algorithms or this approach, then you have to think ahead and construct your data set in order to allow you to run and don't burn your memory. So once now we have transformed the data into this tabular shape, we moved into the data science. We move into DataIQ. So DataIQ, as I mentioned, is was mentioned before, is a very flexible software. And one of the things allows to do is quick QC. So the image over here is a quick statistics just to understand how the data is looking. And you see here that they're looking at the distribution of every attribute is not looking probably good. And looking more into close detail, I can find that some of the values have odd values, right? And everything came from the seismic. So the reason of that is because the data that I export from Petrel might be contaminated, and this is coming from the seismic. So the seismic might have some anomalous amplitudes there that is carrying all over on the calculation of the attributes. So in order to do that, and this can be as a separate test, we can decompose the seismic into panels, frequency panels or amplitude panels, and run this flow specific per panel, and in order to minimize or to target specific frequencies, right? So for this specific case, what I did is just to remove the outliers. However, you can do other things. I mean, in DataQ is very easy to do. You can impute values, you can extrapolate values and so on. But for this particular case, what I just did is just remove them. And after remove the values, which was around 5% of the data, I have a better distribution of the values of every attribute. So what is next now is I can run the unsupervised learning on this data set after has been cleaned, right? So as Sachit was mentioning and showing before, it's very easy to do this on DataQ. I select the features that I want to run for the unsupervised learning, and also I select all the algorithms that I want to use, right? So, and for every single algorithm, you have the possibility to run parallel parametrizations on it. You can, for instance, for the k-means, run for 4, 5, 6, 7 clusters. You can turn on the principal component analysis on, off. For instance, for the DB scan, you can pick any epsilon value that you want, and you can run this at the same time. And DataQ is going to run all and provide you the best one based on your metric, that in this case is the silhouette. So silhouette value is going to give me how the clusters are separated between each other. And based on this metric, DataQ is going to suggest me to use this algorithm or this model to move forward. So alternatively, what you can do as we come back from the previous or from the neural networks that you can do in Petrel, in order to don't run into this, how many clusters I can put on front, you can customize your flow, adding this Python script to create you maybe this elbow method, where it can estimate you or provide you with estimation of, based on the data, how many clusters you can add. And this is what I did. And this is also according what the silhouette value on DataQ was suggesting. So 4 clusters for this data set using k-means is the way to go. So if we look at the data set coming from the model, the information, so we see the distribution of the clusters, the future of importance, in this case for the attributes, which one is the one is giving me more information, and the separation of the clusters. Then the output data set, when I'm interested, is this one. Basically, is the same data set that I use for input, but it's going to have an extra column at the end with the cluster labels on it. So you see the cluster 0 is the predominant with almost 50% of the data cluster on there, followed by the cluster 3, 2, and 1. So now let's go back to Petrel and you see the results. So this is the target area. As you see, this is the area that I select. We see the channel here. And what I'm going to plot now are the clusters 0 to 3 and see how it's doing the classification. So the clusters basically is looking at the channel, right? Which is the most important part. So it's looking at the channel, it's looking at the boundary, and even though it's capturing some of these amplitudes over here that I was probably mentioned that are part of another set of channels over here. And even though it's capturing some of the geology inside of this area, right? So also I want to mention that it's important the interpretation of the surfaces, right? So you see here, this is the flat area I was mentioning earlier. So this is not geological. So I'm missing information that is valuable for this part, which I'm just extrapolate this surface over here. But the better you capture the surfaces for your constraint, your box, the better, because the layers that you define will follow the structure of the interpretation that you are pointed out. So also you might wondering where are these white spots or these empty spots. Those basically are the data set that I removed early. But again, what we can do here is we can filter the data as a frequency panels, or we can impute, or we can do another treatment on the values. So what would happen if I could have left the outliers? That will have misleading on the calculation of the clusters. So see here is mistakenly clustering into this area. So this is why it's important to treat the data, and especially outliers, beforehand. So this is a comparison of what the neural network inside Petrel will do versus the unsupervised learning. The neural network is trying to capture the channel. However, ICS is more contaminated with some noise. And also here, these neural networks don't give me the chance to remove the outliers. So this is just for a comparison of the two methodologies. But how can I know that this is actually right, and this is our fishes coming from the channel? So luckily we have a nearby well over here, which is basically crossing the channel, and you see this intercalation of yellow, orange, all the fishes. See, it's a lot of going on here. And then at this and this edge, I have this area which most likely is low porosity, low probability, which is being captured with this other set of clusters. So this giving a better guidance that the classification is moving into the right direction. So also, what else can I do with this information? Well, once you have the clusters loaded in Petrel, you can split them. So you can get the cluster associated just with the channel. You can leave the cluster associated with the levees probably, or with the basin, and then you can start creating products out of these ones. So you can create polygons around the channel. You can create maps. You can lead to interpretation. So you can use tangible products that you can pass along your team to start either supporting interpretation or create new interpretation. So this is a very handy tool. So if we look like more into detail, for instance, at the fishes that are being calculated into the channel, we can see that the fishes 1 and 3, now I'm calling fishes 1 and 3 coming from cluster 1 and 3, are semi-parallel with high amplitude and low frequency. So we can see here the distribution of the cluster and the frequency is a low frequency. And this most likely is corresponding to the reservoir. Probably is a well-sorted sandstone with coarse grain size. So this in terms of the channel. So exploring this part over here, which is maybe a basin plane or part of the levee floodplain. So those associated with the cluster 0 and 2. So we see here is parallel events with low amplitudes and high frequencies. So this is most likely associated with seals. So no reservoir here, low porosity, right? So, and I was explaining earlier, probably this system that I see here that the classification is identifying probably belongs to a complex set of channels, right? So as we see here in the schema, one channel sitting on top of the other one, so it's quite complex. So this is some results from another project. I don't have the seismic, but I have the seismic, but I don't have show rights to show you, but I can show you the classification. So this also saw the k-means as the main algorithm to do this classification. And you can see here how clear the separation of the fishes and the geological input is providing. And you see here overlay some interpretation actually done by a senior geologist beforehand. So this geologist did the interpretation using just seismic attributes and the seismic images. And when we overlay the seismic, when we overlay the clusters on top of the interpretation, we were just glad to see that a lot of this one was alone of what the interpreter was looking. So the machine is identifying what this interpreter was doing on their hand. So what I was explaining before about the retrainable model, this test was done on the same survey. So what we did here is just to split the data in two data sets. So the train data set on the top in the north area and the test data set on the south. And we extract independent data sets for each one. So we run the clustering on this train data set, and we create this retrainable model on this area. And then we use this model to score the test data set and just to see how the classification is doing using the information from this model. And the results were very, very promising, very good. So you see here how well it's capturing. So now in terms of running time, this scoring, it runs in seconds. So it's very, very quick because it's using the information and the centroids that has been already calculated for the big data set. And this is very useful because imagine that you have a big area that you want to cover. You can just extract a small area, area that is best representative on the geology, and then you can expand that one on the scoring that using the model. So, and this is aligned what Mihir and Sachit was mentioned earlier, that we are looking with these solutions to expanded these applications, not just exclusively for people who has data science background, but that people who geologists or interpreters that they are not into the data science world can use this technology, these tools to approach and to create tangible results on the daily projects. So what we have created is a connector that we can load and data sets directly into DataQ. So with a simple click here in Petrel, a new window will pop and you can just dump the information I was describing, click run, and the whole flow is gonna run in the back end of the in DataQ, and eventually is going to provide you the data set that you can QC and carry on your project. So this is what we're looking at in terms of technology. So to connect domain with data science, and not necessarily that the domain people need to know what is happening in the background to use this technology. So I think this is my last slide. Probably we are a little bit early, so we have some time for Q&A. So I'm happy to take the questions. So thanks so much. Oh, sorry, last one. I have to say this. Thank Western Yukon multi-client for the permissions to use the data for this presentation.
Thank you, David. Thank you for the presentation. Thank you for interesting information shared. We have had a few questions in the chat box meanwhile from Soraya that have been addressed by Mihir. And the next question comes from Bara Osman. The question is, why is train and split done spatially, north and south? Shouldn't it be a random selection based on the proportion, for example, 80 to 20?
Right. So when we're talking about seismic, it's not that easy to split in terms of a single standard data set, because we need to keep the proportion especially, right? So when we are trying to train a model in an area, we have to think in a 2D dimensions and see how is this splitting will make sense for me in order to apply the model in a spatially way. The selection 80 to 20, it's a rough here. What I did was in terms of kilometers. So based on my whole data set and the square kilometers, I tried to keep the proportion 70 to 30 to split the data set based on the polygons that I create on Petrel. That was done in this way to keep the proportion, and more important, to represent a data set that eventually I can use to propagate the clusters along other data set areas. I'm sorry.
Okay, thank you, David.
Does it answer your question?
Well, I will let Bara Osman type in if he or she has any clarifications. I guess from my side, following clarification would be, or probably my understanding of the question is it an alternative to do the split not spatially, but rather basically have a split of the data within the same area of whatever it is, 70 to 30, 80 to 20, and then train it on those 70% and then apply it on the 30%, rather than do the split spatially with the potential risk of having some features in the 20% that are not in the 70%, or and then you might have some potential bias that you won't be able to cover. I'm not a geophysicist, so I'm sorry if I'm talking vague, but yeah. Yes, this is my understanding of the question.
Yeah, and I think here is
Yes, you should ask questions, and if you don't mind, can you unmute and ask? That's more interactive. So, David, not sure if you're reading the chat, but I may read it for you.
Yes,
so there is another question. Okay.
Yes, please. Yeah, the question is, what will be the difference of the fine and coarse interpretation of seismic horizons? So, if I understood the question is the differ in terms of inline and crossline increment. Yeah, so when you do interpretation, you normally work on grids. So the finer the grid, the better you can capture the difference between inlines and crosslines. The coarse grid, obviously you will miss things in between, right? So the coarse grid obviously is going to take you more time. And a course 800 by 800, just to throw a number there, you can do it quite quick, right? So, and also on top of the increment, you need to considering like auto tracking settings, what is your target, and yeah. So, but I would say it's mainly about how much time do you have to do the interpretation. If you're talking about that you have a live project, you have to look very careful on the time in order to don't compromise delays. So yeah, but in this particular case, the surfaces needs to be I will say you don't need to have a very fine interpretation, but at least good enough to capture the main geological settings. Because as I explained, when you define your layers run parallel on the surfaces. So then you don't want to have straight lines that will cut probably geological settings, and that is going to misleading on the results.
Thank you, David.
All right. Any other question?
Any other questions?
Any feedback?
While the audience is thinking of the next question, I have one from my side.
Yeah.
It's like a general questions about the platform, the AI platform. I saw it's an interesting idea of, as you say, democratizing the use of AI and machine learning, and using the UI, way of deploying the models. The question is about the routines that you have there as blocks. Are those routines deployed by users or by coders that how's it called, work on the development of the product? And how do you ensure QAQC of those routines?
David, you want to answer that, or
just to follow up?
Yeah.
I mean, the risk that I'm seeing is that there might be a case. I mean, if there is a case of a potential error in any of those routines, it can be quickly, it can be quickly spread over into different projects. So yeah, the question is how do you prevent that from happening?
So it was a bit long question though, but I will ask I'll repeat what I understood your question is, and correct me if my understanding is wrong, right? So your question is, one side of the question is how this routine of the code, source code of the environment or the application that is maintained, right? So there are two, if that is correct, then there are two sides of it,
Yes.
right? One is the application source code itself, and because it's a professional application, it's a commercial tool. So that is given as a customer that we are catering to. They have the platform, and then they don't need to worry about the application itself. Now, the second side of it is people working in collaboration to build a AI project, right? For example, And that involves, let's say, sometime mix of, as Sachit was showing, a mix of visual recipe, and then there are a mix of code recipes as well, right? So whoever is participant on those projects, so there is a governance in place in Data IQ as an application. So you don't have access to everything to everyone, right? So you have access control, you have a governance in place. So that's how you control who has, let's say, data science profile access and who has basically a domain access. So they domain people can go and give a feature selection feedback that if I'm doing XYZ prediction, then selecting ABC features, for example, it doesn't make sense. That maybe data scientists may not know that this is important or not, right? So those are the collaboration, but everything is access control. Now, the third part that I understood is on the scaling side of it, right? Which is once the project is done and it's found working, how do you scale it, right? So then there are deployment and scaling mechanism, and then there are triggering mechanism as well, right? So not a lot of time, this data science workflows that we do for our customer, they are not like every time it is running, right? So it is based on a trigger or an event, right? So you could set those things. And then there is a continuous feedback also, right? So if, as and when you're starting using machine learning models, you want to make sure there are no lags, and then the model is doing the accurate prediction in future also. So there is a feedback, and then there is an optimizer as well, right? So then you start using that in a core pure data science world, and this is how it is being maintained. I hope I answer your question. I'm not sure if I was on.
You did indeed, Mihir. Yeah.
Okay.
You did it in the first half. So it's basically, my understanding is it's based on the different access roles of different users that have different pricing. Yeah, and different way of using the platform. There is another question from Bara Osman. What are your thoughts on a mixed approach of supervised and unsupervised solution? Is it something that would add value, and should we explore it?
Yeah, sorry, Mihir. Before I was answering, I was on mute and then unmute. This is a hard day for the headsets for on my end.
No problem. No problem.
Coming to the question, well, for this particular case, we are looking at an unsupervised solution because we don't have so much information on front. So, and the aim of doing unsupervised is because we want to see what are the patterns on the seismic data through the attributes, right? So following the supervised approach, probably we need some sort of labels on front information that maybe we want to predict, which is not the case for this particular use case. Maybe eventually what we can do, if we have some well information, we can use this information to try to change the approach. But at the moment, coming from the nature of the project, which is coming from zero information, but just seismic, and to understand the patterns inside of the seismic data, unsupervised learning is the best approach. Not saying, I'm sorry, let me rephrase that. It's the approach to follow. We can also do some deep learning, but this is something is still under testing.
Okay.
Okay. Any other questions from anyone in the public?
If no question, I would like to wish you a very good luck with your hackathon. When you really do the hackathon with the data set, hope you could win the competition. Good luck to everyone.